Okay, solving problem F16 11. Okay, so we have a rod pushing here, which pushes on this rod, which turns the wheel. So if the rod is moving out at 60 feet per second, pushing on the rod will push up right there, and let's call that a VC. We want to know the angular velocity of the link, so the link is rotating that direction. So we know VB is going to be negative 60 in the I direction, and we know VC is going to be equal to VC in the J direction because it is going up. It's nice that it happened to be straight across, because then at that point we know the velocity is straight up. If it had been any other angle on that wheel, it would have had a component in the X direction as well. But since it's straight across, it is a vertical motion. Okay, and then omega is spinning like that, so we know that omega BC is going to be an omega in the negative K direction. Alright, now, so we'll start with the equation VB equals VA cross omega, or plus omega, cross RB over A. Now, instead of B and A, we have B and C. A doesn't matter. So let's change this equation. So we're going to do VC equals VB plus omega cross RC from B. Okay, so putting these into this, we have VC in the J is equal to negative 60 in the I plus omega, which is negative omega in the K, crossed with RCB. So RCB is this distance and this distance. Now if that's 30, then this is 30. And this is 2.5 cosine 30, or 2.165. And this one is 2.5 sine 30, which is equal to 1.25. And that's feet on both of those. So this is crossed with negative 2.165 in the I direction, and 1.25 in the J direction. It's kind of getting tight over there. Let's put a second pair of pencils there. So let's do the cross product. So the cross product, I'm going to do it this way. I, J, K, I, J. And we're doing W cross, omega cross R. So omega is negative omega in the K, and we're crossing that with negative 2.165 in the I and 1.25 in the J, negative 2.165 in the I and 1.25 in the J. So that gives us a double negative, so 2.165 omega in the J direction. And we have a negative going up and negative there, so double negative plus 1.25 omega in the I direction. So that's the cross product. Let's put that back into this, and we have VC in the J equals negative 60 I plus, now let's put the I first, 1.25 omega in the I plus 2.165 omega in the j. And putting parentheses around that's not really doing a whole lot of good, so let's delete that. Now looking at this, we don't know VC, we don't know omega. So what we have to do, we need two equations, and here we only have one. So we will separate this equation into two. So that is because we know the components add. So VC in the j has to be equal to 2.165 omega in the j, and 0 is equal to negative 60 in the I plus 1.25 omega in the I. Let's start with that one because that has one, so in one variable. So in the I direction, we have the equation 0 equals negative 60 in the I. Let's take out the I since we're in the I direction. Plus 1.25 omega. Moving that to this side, omega is equal to 60 divided by 1.25, which is 48 radians per second. Now pulling the second equation, VC, this is the J part, VC is equal to 2.165 omega. So VC is equal to 2.165 times 48, which is equal to 104 feet per second.